If you've ever wanted to make a working hinge in Tinkercad, you're in the right place. In this video, I'm going to walk you through the simple process of building a basic pin hinge using a few easy shapes inside Tinkercad. This is a great beginner-friendly project for anyone learning 3D design, and it's perfect for boxes, lids, doors, small enclosures, and print-in-place projects. By the end, you'll understand how to create the hinge pin, how to build the interlocking loops, how to attach the hinge leaves, and how to add the right clearance for 3D printing. If this tutorial helps you out, make sure to hit like, subscribe, and turn on notifications for more quick Tinkercad guides. Alright, let's jump in. First, open Tinkercad and create a new design. Before you start placing shapes, it helps to think about how a hinge works. A hinge is really just two connected parts that rotate around a center axis. In Tinkercad, that means you will be building a center pin and then adding alternating loops on each side of that pin. Once those pieces are lined up properly, the hinge can move the way a real one does. To begin, drag a cylinder onto the workplane. This cylinder will become the hinge pin, which is the middle part that everything rotates around. Rotate the cylinder 90 degrees so it lies horizontally instead of standing upright. Then resize it to a small diameter, something like 3mm or 4mm depending on the scale of your project. Keep the length long enough to match the width of the hinge you want to create. This pin needs to be thin, smooth, and centered because it defines the rotation point for the whole hinge. Next, you're going to create the interlocking loops around that pin. These loops are the round sections that wrap around the hinge and allow the two sides to connect. Drag a tube shape onto the workplane. Like the cylinder, rotate the tube 90 degrees so it's also horizontal and aligned with the pin. Adjust the inner hole of the tube so it fits around the cylinder with a little bit of space. If your pin is 3mm, make the tube hole about 3.4mm to allow for 3D printing clearance. That small gap is important because printed parts need room to move, and if the fit is too tight, the hinge may fuse together after printing. Now duplicate the tube and slide the copies along the pin. You want several loop sections spaced evenly across the hinge. A simple pattern is to alternate which loops belong to each side. For example, one loop can belong to side A, the next to side B, then side A again, then side B again. This alternating arrangement is what creates the interlocking hinge structure. If you're making a longer hinge, you can add more loops, but for a beginner project, 4 loops is a very practical starting point. Once the loops are in place, it's time to assign the sides. Select the first and third tubes and treat those as one side of the hinge. Then select the second and fourth tubes and treat those as the opposite side. This alternating pattern is what lets the hinge fold. Take a moment here to line everything up carefully because even a small alignment issue can make the hinge look uneven or prevent it from moving correctly later. After that, you need to add the hinge leaves, also called flanges. These are the flat rectangular parts that connect the hinge loops to the rest of your model. Drag a box shape onto the workplane and flatten it until it's about 2mm or 3mm thick. Stretch it so it covers the loop section belonging to side A. Then move the box so it overlaps the tubes on that side. When the box and the loops are positioned correctly, group them together. This creates one solid hinge half. Now repeat the same process for side B. Add a second box on the opposite side of the hinge, align it with the remaining loop sections, and group those shapes together as well. At this point, you should have 2 separate hinge halves that interlock around the central pin. If you've done the spacing correctly, the hinge should look like a real mechanical hinge with alternating loops and a clean pivot axis. If your goal is to 3D print the hinge as a print-in-place design, there's one more very important detail to get right. Clearance. You need a small gap between the rotating tubes so the parts don't fuse together during printing. A gap of at least 0.3mm to 0.5mm is usually a good starting point. Also, the pin should be grouped to only one side, while the other side stays floating around it with that tiny gap. That way the hinge can print as a single piece but still move after printing is complete. As a final check, zoom in and inspect the alignment from the side and top views. Make sure the hinge loops are evenly spaced, the pin is centered, and the leaves are attached cleanly. If anything looks off, it's better to fix it now than after exporting for a print. You can also duplicate this hinge design and scale it for different projects like small boxes, cabinets, electronics enclosures, or custom mechanical parts. And that's it. You've now learned how to make a simple hinge in Tinkercad using basic shapes. This is one of those foundational skills that opens the door to so many other KD projects. So once you understand this method, you can start experimenting with larger hinges, stronger hinges, and even more advanced print-in-place mechanisms. If this video helped you, please give it a like, subscribe for more Tinkercad tutorials, and share it with someone who's learning 3D design. Thanks for watching, and I'll see you in the next one.